Okay, let's do energy problem. So this is energy. And this is going to be a gravitational system. So we're going to have a gravitational system. So let's see, what do we have? We have here a particle. Okay, we have here some, okay, like a building or something. There, that's your building. And we know that this is the floor right here. And then this is how tall it is. So you have your height. This would be your height, all this. This is going to be the height. Okay. And the height of your building. So it's going to be this one right here. And you have a particle at the top. Here's your a little box or particle that has a mass m. And what you want to know is that if you let that particle go, if you let it go, it's going to start falling down, and it's going to pass through a point at the middle right here, at the middle of the path on his way down. And you want to know what is the velocity in that point. Let's call it point A. And we want to know what is the velocity on point A. This one right here, let's call it point A. So once you let it go over here at the top, you let it go, it comes down, and then it's going to pass through this point A, and then it's going to continue on its path coming down all the way to the floor. So it's going to hit the floor over here, and let's call this point B when it hits the floor. And we want to find the velocity when it hits the floor. So what is the velocity in point B? So our questions are, what is the velocity when it passes through point A on its way down? And what is the velocity when it passes through point B on its way down? And as you can see, point B is on the floor right here when it hits the floor. And then you got your height over here. This is going to be your height. So let's make the height over here a better height, a better looking height. So this is going to be the height of your particle, and then you let it come down. Okay, so how do we solve this problem? Well, we have for this gravitational system, remember that this is happening on the surface of the Earth. And on the surface of the Earth, you have a gravitational field. That means you have vectors all over the place. And this is G. And we know that G is 9.81 meters over second square. So you have a gravitational field pushing towards the center of the Earth. And you let your particle that has mass, you let it come down. So the total energy is the kinetic energy, which is 1/2 of the mass, velocity to the square, plus the potential energy, which is mgh. Okay, so that's the total energy of your system. What do you have? You have kinetic energy plus, this is going to be your kinetic energy plus your potential energy. Okay, potential energy over here. And if you add those two guys, you got your total energy right there. Okay, so over here, before you let your box come down, before you let it go, the velocity is 0. So the initial velocity is going to be 0 because you're not going to push it down. You're just going to let it go. Okay. So then what do we have? We have that the total energy is going to be 1/2 of the mass, 0 to the square, because the initial velocity is 0. The initial velocity is 0. because you just let it go. You don't push it down. Plus mg and whatever the height is. Okay, so there you go. You have your total energy. So this term is going to cancel out. It's going to be 0. Okay, so your total energy is going to be just mgh. That's your total energy right here. Okay, so then you let it go and it comes down on its path, and then it's going to pass through point A. So when it passes through point A, the height would be this one right here, would be h over 2. That's your height. So the total energy, we know now that the total energy of this system is mgh, and that's equal to 1/2 of the mass velocity in the point A to the square plus mgh mgh over 2. And that would be at point A. That's what's going to happen at point A. This is on point A. Okay. So we can send this term to the other side. So it's going to be mgh minus 1/2 of mgh. And that's going to be equal to 1/2 of the mass velocity in point A to the square. Okay, so mgh minus 1/2 of mgh is going to give you, this is going to throw you positive 1/2 of mgh is equal to 1/2 of the mass velocity A on point A to the square. And we can cancel the 1 over 2 with the 1 over 2 and the mass with the mass. So gh square root is going to give you the velocity in point A. And now you have a formula to calculate the velocity in point A. There we go. And let's get the other velocity, let the velocity in point B. So we go back to our formula that says that the total energy is going to be 1/2 of the mass velocity to the square plus mgh. But in point A, when you get to point B, when you get to point B, h is going to be 0. The height is going to be 0. So, and the total energy, we know that the total energy of your system is mgh, and that's equal to 1/2 of the mass velocity in B to the square plus mg times 0. So this term is going to cancel out. There it is. And you can cancel the mass with the mass. So 2gh is going to give you, and then you got to get the square root of this, and that's going to give you the velocity in B. So now you can calculate the velocity in A and the velocity in B. Okay. So if the over here, let's say g is 10 meters per second square, and h is 10 meters. So you got to get the square root of all this. So your velocity in A would be, in that case, it's going to be 10 times 10 is 100. The square root is going to be 10. And then you got meters squares. You got meter square over second square. And then you got the square root of all that. So it's going to throw you meters over second. So that's going to be meters over second. There you go. And the velocity in B would be 2 times, let's say it's 10. And h, we said, is going to be another 10, and the square root of this. So this is going to be 10 square root of 2 meters over second. And that would be your velocity in B. So there you go. You have an energy problem where you are using a gravitational system, mechanical gravitational system. And you have found the velocities in point A and the velocities in point B as this particle here that has mass m is coming down. As you can see, the velocity is independent of the mass. We hadn't used the quantity mass for anything in this problem. And there you go, you got another problem there. Thank you, and we'll do more of these.